Good day. My name is Brian Smith. I'm a student at Full Sail University. I'm going for my mobile gaming master's, working on my capstone project, War I Flying Circus. The past 3 weeks have been heads down development, milestones 7, 8, and 9, and largely wrapped around creating an AI, artificial intelligence, for an automaton, in a computerized opponent to fight against in a dogfight. Now, with this, there's really two important messages that really resonated with me through the course of this past 3 weeks. And the first is with any sprint, you really want to be delivering that business value, kind of an enhancement to the application. And so while the first sprint, milestone number 7, was all about creating the walls of heroes and the wall of aces, really my goal with that was, sure, I need that functionality and I wanted to have that ability to display this information. But my technical goal, was to be able to push data to the Firestore database and to read data from the Firestore database. That was very important then for me to be able to deliver then the 3 different sub-sprints, or the 3 different major tasks that I needed for the AI automaton work. And those 3 major ones was first of all, saving all the 5 tuples, basically the unique relative positionings of the different aircraft and the maneuvers that the humans made, calculating the best maneuvers, and then reading that back in from the Firestore database. So the first was reading and writing to Firestore. Second was just the mathematics, and then the third was reading from Firestore. So that goal, so that first milestone number 7 was I had some functional business value to it, but really had, from an AI point of view, had a lot of key technologies, key skills that I had to learn before I was able to even have a fighting chance of accomplishing the AI in about a 2-week period. So then I focused on the AI bit, and I was able to copy and paste and reuse a lot of the pushing to and the reading from, the pulling from the Firestore database. So that was very important. Then the second big thing that was really key to this was taking something really complex. This creating an AI opponent had a lot of moving parts, a lot of very heavy mathematics. And what I did is I sat off to the side and on a piece of paper outlined, here's what the task that I need to do in these particular steps. And then I focused on a particular task or a particular step with that, and got everything all tested and working for that step, and then went on to the next one, got it all tested and working, went on to the next one, testing and working. And so I really spent the time to make sure that the code I was writing was operating as best as I could. I went back, I refactored a lot of the helper routines that we're using that I had created months ago, for a different purpose, but now I could reuse them or reuse a portion of them. So I refactored them to make sure that they work for both places and retested everything. So it was a very careful kind of endeavor. And the wonderful part was, after I did all that, little individual steps and sub-steps, basically it was just stringing them all together, and it worked. Sure, a few bugs here and there, but really largely worked. And so it really was a great exercise to do the same kinds of things that I've been doing from a programming point all along, which is really breaking up complex things and making them simpler, and then putting all those simple things together to make something complex. So it's nothing new. I didn't invent anything with that, but it really was fun to kind of see that all work and come together. The other thing I've done here, I'm going to share my screen, is what I did is put together a little bit of a presentation. Here we go, let me see this. For kind of trying to define this, the AI automaton that I created, the AI logic and all that. So I had discussed this in great detail at the end of the milestone number 9, when I finished with the AI automaton. But I'm trying to put down on paper some of the things that I did. I'm going to take you through this very quickly, but just kind of a problem statement. And as I've mentioned before, this is really like playing rock, paper, scissors in terms of trying to create a heuristic or an algorithm to calculate what is the best move, because you really don't know like in World War I Flying Circus, because both players are going to fly their biplane at the same time. They're going to pick their moves independently, but then the moves are all take place at the same time. So it's a simultaneous resolution of the maneuver. Because of that, it's like playing rock, paper, scissors, where you don't know what the other person's going to throw. So really, anything you pick has got a 1/3 chance of winning, 1/3 chance of losing, and 1/3 chance of a tie. But it turns out that really that rock, paper, scissors is not purely random, because we humans are not purely random creatures. And so there are some advantages and some strategies that you can use in playing rock, paper, scissors. So decided to give that the same kind of thought to creating an AI automaton. Is if we can know ahead of time for a given relative position of the biplanes and the available maneuvers from one biplane and the available maneuvers of the other biplane, that creates a 5-tuple of information. And then if it can have that as a unique key, and then if I know what the humans generally do in that relative position, given the maneuvers that are available to them, what kind of maneuver that they would generally pick, if I can get that information, that 5-tuple, I can pre-calculate then the best move for the AI automaton to swoop in behind and get that shot off against the human. So that was the theory as that I went into it. So that was kind of the problem statement. And then this is a definition of the unique 5-tuple, which is basically angle off you got an object biplane. Let's just call that biplane number A. So it's always in this galactic center. And then I needed to know 3 pieces of information to know where the other biplane B is in a relative geographical relationship to the biplane A that is, again, always in the galactic center, always facing north. And the first one is the angle off the bow. I'm going to go into greater detail with this. The second is the relative facing of B relative to A's facing. Third is then just simply the distance. And then you marry that with the available maneuvers for each one, and that gives you a unique hash that defines what is the characteristics of the starting position for this turn that the human then made the decision to say, I'm going to go and make this maneuver. So I needed to know all 5 of those pieces. There's additional pieces I'm capturing, but I have not turned it into a 6-tuple, 7-tuple, 8-tuple, and I will do that in the future. But right now, I've just got a 5-tuple for what is the unique characteristics of this turn for that human to make that maneuver, so that I can, if I know all those and I can add up all those, then I can calculate the best counter maneuver for that from the AI automaton's point of view. So again, that's the theory. So let's take a look at the angle off the bow. So if we take a look and we look out, if our biplane, again, always in galactic center, always facing north, is in the center of all these hexes. If we're looking out, then the 5 hexes around us, including the one that we are in, then the angle off our bow, if our bow is straight ahead and that's 0 degrees off of our stern is 180 degrees. We've got negative degrees to the left and positive degrees to the right. The angle off the bow then is that position relative to the us facing north. And in this case, I've got other B biplanes out there, and in this case, all 4 of them are 60 degrees off the bow of our galactic center biplane. And if you add up all the different positions that can be in terms of the unique angles, you notice if the enemy biplane is here, that's also 0 degrees, and that's 0 degrees, and that's 0 degrees, and that's 0 degrees. And so all those, if the enemy biplane is in front of us, that's going to be 0 degrees. So that's only one unique angle off of this biplane A's bow. Add those all up, you get 36. Then it's the relative facing, and then even if the enemy biplane is in front of us, it can be then in 6 different relative facings. Now it's not relative to some kind of global or world coordinates. It's relative to the facing of the biplane that's in the galactic center. And so this biplane here and this biplane both facing in the same direction. So the relative facing is 0 degrees. If here, this biplane is turned off of the facing from this biplane, 60 degrees, a positive 60 degrees, and here it's turned off a negative 60 degrees. And you can see the other examples there. So there's only 6 different relative facings based upon, because we're each biplane in War I Flying Circus, each biplane is inside that hex, and then as one of 6 facings is where it can end up or start its turns. The other is distance. This one actually kind of surprised me. It's a lot less distances than I originally thought and calculated. Just 9 of them, and the biplanes in World War I Flying Circus can be on top of each other. So that is one distance is 0. But then, if you take a look at it, you've got 6 hexes around there. But if no matter which hex the biplane is in, there's just one distance. And it's in World War I Flying Circus. It's 200 meters. So that'd be a 200-meter distance. Here, there's just 2 because if you go to here, well, that's the same distance as to here from there to there as it is to there, and then also around the compass wheel, as it were. And then for the purples, same kind of thing. This is distance 3. This is something a little bit less than distance 3. This would also be distance 3. So that's the same distance, and this would be the same distance as that one in terms of relative to there. And then for the oranges, the yellowies colors over here, same kind of thing. Add them up, use the 9, and that's how you get then the around 2,000 unique starting positions. Add that then to the maneuver hash, and you get a lot more of these unique starting position 5 tuples for the database. And speaking of the database, here was then breaking this really super complex thing down into smaller sprints and then sub steps, and then pulling them all together. I talked about with the first milestone, number 7, was was about the walls of, but the goal there was to learn how to push information to FileStore and to read and query information out of Firestore. So sprint A really was about capturing all that raw information, and that was hard enough in terms of the mathematics to generate all that 5 tuple, but I just pushed that out to a raw. So I'm capturing all the information that I can, because I don't know, well, I know some of the things that I want to use in the future, but I'm capturing as much as I can right now, so I can use that in the future. But if there's enough information in here, you can see there, this is the available maneuvers for this airplane, available maneuvers for the other airplane. It talks about distance and angles off of bows and relative facing angles. So that right there, that's that 5 tuple that we're talking about. And there's then the maneuver, the F1. You can see it's pretty small. The F1 is the maneuver. And I'm capturing other information, which I think will be useful in the future, but I'm not doing anything with it right now. But that's the first step, capturing the raw information. Then the second thing I did actually is I started on this sprint C and actually created then this 4th game mode. And I hard-coded the AI best moves database. Just hacked it in, hard-coded it in, and then I was able to read that in, and then to validate that I created this 4th game mode, the dogfight against the automaton, that it played well. There was surrendering, there was lost contact processing, and it did indeed pull in the hard-coded AI best moves that I specified. Plus I was able to read things in and write things out, and so it really was just a validation of that. So that was the second big thing I did in terms of the AI. Then the third was doing all this business here, and this is the generation of that, the AI best moves right there, the creating of that by pulling in the previous counts that I would have added up. Of course, if there's nothing there, then I'm pulling in nothing, pulling in all the raw data, merging that in other words, generating those 5 tuples, and then keeping track of this is the maneuver numbers, and keeping track of the number of times that the humans have done that maneuver number. For example, for this unique 5 tuple, the humans 17 times did maneuver number 1. So that's the merge. Then I push that back out, so that's information's available out there, and then I read that back in, calculating my AI best moves, and I write that back out so that the next time we fire up World War I Flying Circus, it reads in that AI best moves and kicks the humans tush. So that's kind of an overview of really the lessons learned. The big thing, 2 big things, right? One was, of course, breaking things up into small pieces like we're looking at here. And the other is, I like the idea of the sprints. I've never used sprints in the past. I've been waterfall my entire programming career. But I like the idea of the sprints in terms of delivering business value. And I think what I've been able to demonstrate as part of this master's is that it's not just, demonstrating business value, but what I've been doing is, as I've been packaging up these milestones in terms of, like this case, 7, 8, 9, really mindful of the things that I need in the future. And as I'm bundling them together, I am leveraging the things that I need to build for, in the past, for the things I need to build in the future. In other words, tying things together and really leveraging the business value, but making sure that I'm using it not just for one sprint and then throwing it away, but making sure that I'm using it, and that's going to be a basis for something that I'll be using then in the future sprints. So great opportunity, and I really learned a lot. There was things that I had obviously never done. You're working with an online database like the Firestore that was all brand new. I had done the skunk works in terms of the authentication, anonymous and signing in authentication. So skunk works there. So played around a little bit with the Firestore, and again as a precursor to actually making this happen here. So it was a great 3 weeks. I'm really surprised, honestly, that I was able to accomplish everything. But it really was basically just good old-fashioned programming, breaking things down into smaller and smaller pieces, and then understanding that, building that piece, testing the dickens out of it, and then setting them, putting them all together, and then watching it work, and of course fixing a few bugs along the way. So again, thank you for the opportunity, and thank you for all the fingerprints and the constructive criticism that I've been getting from you, Professor Penny.